In this video, we'll be going over the bottom-up array approach of unique paths too. So in our previous 2D matrix approach, we can see that in each of the iteration, we're only relying on values from the current row and also the row below. This means we can use a single array to represent our 2D matrix. Now let's go over the thought process. So in the 2D matrix approach, in each of the iteration, we are only relying on values from the current row at R and the row below at R plus 1. This means we can use a single array to represent our 2D matrix. Then in each of the row iteration, we will be replacing or updating the values from the previous row iteration. Now let's go over the pseudocode. So we're going to create an array paths to keep track of the total number of unique paths. Then we're going to iterate through, this one stays the same, we're going to iterate through the rows and then iterate through the columns. And if the current cell contains a 1, that means the number of paths is going to 0. So we're going to set path C to 0. Then we continue the next iteration. If RC is at the bottom right corner, that means we have found one possible path. So we're going to place 1 at the current cell. Now we're going to create a variable, current, and set it to the current cell, the current number of paths. Then we're going to reset our current number of paths to 0. Now if RC is not at the last row, that means we can move downward. That means we can increment the current number of paths by the number of paths moving downward, which is current. So because paths R plus C is the same as path C now, so we can increment path C by current. If C is not at the last column, that means we can move rightward. So we can increment the number of rows, the number of paths by moving rightward. Since this is the same row as our current cell, we can just do path C plus 1. Then we can return paths 0, which is the total number of paths starting from the top left corner. Now let's go over to time and space complexity. The time complexity stays the same because of our nested for loop. But our space complexity changes because we're using a paths array now. So it's just going to be O of n, where n is the total number of columns. Now let's go over the code. So we're going to create our array now. Our paths is converted to an array, and it will still iterate through. If obstacle RC is equal to 1, the total number of paths is equal to 0. Then we continue the next iteration. If RC is at the bottom right corner, then the total number of paths at the current cell is equal to 1. Now we want to save our current number of paths before resetting it back to 0. If R is not equal to n minus 1, that means we can still move downward. So we're going to increment the current number of paths by the number of paths moving downward. And then if C is not at the last column, then the number of paths will be incremented by the number of paths moving rightward. And then we can return path 0, which is the total number of unique paths starting from the top left corner. Let me know if any questions in the comment section below.